Alrighty, hello class. This is 4.2 Notes, Reflections, and Lines of Symmetry. And so this is the page after your 4.1 Practice A, and of course this will vary, but we're talking about reflections and lines of symmetry. So when I think of reflections, I think of the two letters FL in the middle, and I turn that into the word flip. So that means reflection, like in a mirror, I am flipping over an axis, or when I look into the mirror, my reflection is reflected off the mirror so I can see myself. So let's talk about example 1. So example 1 says reflect the triangle ABC across the x-axis and name the coordinates. So point A is -3, 4, point B is 4, 2, and point C is 3, 7. So when we reflect it from the x-axis, we need to make sure that we flip it the same amount of times from the x-axis as well. So this is what we're looking at, the x-axis. So how many points, or how many coordinate points, are we going from B to the x-axis? Well, if we count, we have 1, 2. So if I'm going from there to the x-axis, I need to do the same amount going away from the x-axis so I know that it flips the correct amount. So I have 1, 2. So B prime will be here. Okay? And B prime is 4, -2. Okay? Let's do the same thing for C. I have 1, 2, 3, 4, 5, 6, 7. This is 7 units away from the x-axis, so I will count down 7 more. So I have 1, 2, 3, 4, 5, 6, 7. So that is my C prime. And the point for C prime is 3, -7. Okay? And I'll do the same thing for A. 1, 2, 3, 4. 4 units, so I go away 4 units. 1, 2, 3, 4. And that is my A prime. So I have flipped C and B and A. So I have flipped, like to say, to take my hand, I'm flipping it over. That's what I did with the x-axis. I just flipped it over. And just hold on a second while I get this to focus correctly. Awesome. Okay. So let's go on to example 2. Example 2 says reflect XYZ axis across the y-axis. So the y-axis is definitely going vertical, up and down. Okay? Sorry about that. Coordinate A prime is -3, -4. So let's answer this question. It says, do you see a pattern? So it looks like my x values stayed the same, but what happened to my y values? My y values became negative. So my y values became negative. So it all went from positive values to negative values. So let's see what happens if we reflect a figure across the y-axis. So the same deals apply. I moved over 2, and I move over another 2, so I have x prime. And then I have y goes 1, 2, 3, 4, 5, 6. That's 6 units for the y-axis. I'll go out another 6 units. 1, 2, 3, 4, 5, 6. That's my y prime. And the same thing for z. So now I have reflected it across the y-axis. So our original coordinate points for x is 2, 4. And then when I flipped it, it went to -2, 4. For y, my original coordinate point was 6, 2. But when I flipped it across the x-axis, my y prime is -6, 2. And the same thing for z. Z, I have 2, -5, and when I reflected it across the y-axis, it turns to -2, -5 is my new coordinate point. So, do I see a pattern here? So it looks like my x values changed, but my y stayed the same. So my x values became negative. Okay? So think about this. I have my x values, my y, across the x-axis, my y values changed. And if I'm dealing with the y-axis, my x values changed. So see how they're interchangeable that way. So let's look across for example 3. I have reflect RST across the line, y equals x. So here's my line, y equals x. And it says name the coordinates. So R is -4, 6, S is -1, 2, and T is -6, -1. Now with this one, I will give you what R prime, S prime, and T prime are. 6, -4, 2, -1, and -1, -6. So I gave you those points because this is what happens. You can't necessarily count. No, you can't deal with that. There's a rule, and we'll get to that rule momentarily. But let's graph what R, S, and T look like. See if it actually flips across this axis. So I have T prime is -1, -6. And then I have S prime is 2, -1. And R prime is 6, -4. Again, if you do not have a straight edge, please use your ID in order to make these lines perfect as possible. So the pattern here, what happened? My x and y values switched places. So think about when y equals x. If y equals x, then x must also equal y. So I'm able to flip my x and y values. So my x and y values change places. Okay, x and y values change places. So this is where one of those papers did not get attached correctly. So if you go to the very, very last page of your packet, if you go to the very last page, you will see your core concepts on top. And it says coordinate rules for reflection. So this is 4.2 continued. 4.2 continued. So the coordinate rules for reflections. I have if AB is reflected in the x-axis, then my point becomes A, -B. So with -B, we already noted that with the x-axis, my y values changed. Now if I have the y-axis, my x values changed. Then we looked at if we had reflected across the line y equals x, then they switched places. And now let's say if I had y equals -x, then the new image is the point -b to -a. Now note for this one, if you look at your quadrants, you have quadrant 1, 2, quadrant 3, and quadrant 4. Okay? So we know that quadrant 1 has positive values because this side's positive and this is positive. From here I know my x values can be negative, but my y values can still be positive. For quadrant 3, both coordinates are negative. And for coordinate 4, I can have positive x values but negative y values. So that was talking about any points here. So we have y equals -x, decreasing. Then if I had a figure here, let's say I had a heart, and I had to flip it across this axis, all my coordinates end up being negative. So if I went from the first quadrant to the third quadrant, so that is where y equals -x comes in. So let's look at lines of symmetry. Lines of symmetry. It says, what, if any, were the lines of symmetry in examples 1, 2, and 3? So let's look at example 1. We did example 1, and I'm just flipping pages. Example 1, what was our line of symmetry? So that line of symmetry is that line that divides it, and where we either flipped across that axis, or if we flipped across that plane, or that point. So for here, our line of symmetry would be the x-axis for example 1. So line of symmetry is the x-axis. Now what about example 2? So example 2, what was the axis that was our line of symmetry? Y. So y was our axis. Y is our line of symmetry. And then for example 3, we don't necessarily have an axis, but we did flip across a line of symmetry, and that would be our Y equals X. Okay? So on the bottom, I have 6 examples. It says draw the lines of symmetry, if any, for the following figures. So let's see how many I can make with A. I can't really go across because I definitely don't have eyes where my mouth are. And I definitely don't have a mouth where my eyes are. So I can only go down side to side and only have one line of symmetry. What about B? I can obviously go down the middle, and I can go across up and down. I can pretty much connect all my vertices. So that was 1, 2, 3, 4. And then I can also cut in between 5 and 6. So I have 6 lines of symmetry. So C. Do I have a whole bunch of lines of symmetry? I sure do. I can cross it here and here and here and here. There's an infinite amount of lines of symmetry. It's a circle. What about D? I obviously know this one. That's 1. And I can fold it here to 2. But can I really cut across here? No. If you were to fold a rectangle, this point would not meet up over there. So I only have 2 lines of symmetry. Now, E, I have 1 line of symmetry, and I have another line of symmetry, but I also can divide it down the diagonal. So that's 3 and 4. So I have 4 lines of symmetry for E. And then F. Can I divide this any kind of way to make this symmetrical? I do not. I can't cut it this way. I can't go it down the middle. So this one has no lines of symmetry, or none. Okay? Alrighty. So on your next page, at the end of those examples, you will start on 4.2 practice A. So 4.2 practice A. Note, you will have grid paper, and it might be able to do this, but you will complete all of that is required of you for this practice A. And you will just complete this page, and it's only 12 questions. Again, thank you so much for watching, and you have a good night.